Hello everyone, this is Dr. K. Mamata, Assistant Professor, Department of Mathematics, Vardhaman College of Engineering. In this lecture, we are going to discuss about first shifting theorem in Laplace transforms. And the statement of first shifting theorem is, if L of f of t equal to f of s, then L of e power at f of t equal to f of s minus a. So this is a statement of first shifting theorem, and in the same manner we can write L of Laplace transform of e power minus at f of t equal to f of s plus a. Now applications of first shifting theorem leads to the following results, and the first result is, and we use this concept to apply first shifting theorem. As per first shifting theorem, I am considering the term Laplace transform of e power at f of t, and to evaluate this part, first I need to find Laplace transform of the function f of t, and here in this formula I need to change s with s minus a, and as we know L of f of t equal to f of s, then replacing this L of f of t equal to f of s, we get f of s, and changing s to s minus a gives the result as f of s minus a. And we apply this concept to evaluate these results. For example, first one, let us take L of e power at t power n. So to evaluate Laplace transform of this function, first we need to find Laplace transform of t power n, and here we need to change s with s minus a, and the formula for L of t power n is n factorial by s power n plus 1, and here in this result we need to change s to s minus a, and the answer will be n factorial by replacing s with s minus a, we get s minus a whole power n plus 1. So this is a Laplace transform of e power at t power n result, n factorial by s minus a whole power n plus 1. And the second example, Laplace transform of e power at sin bt, and to evaluate Laplace transform of this function, first we need to find Laplace transform of sin bt, and here in this result we need to change s with s minus a according to first shifting theorem. So now what is L of sin bt? L of sin bt formula is b by s square plus b square, and here we need to change s to s minus a, then the result will be b by s minus a whole square plus b square. And one more result, L of Laplace transform of e power minus at cos bt. So here first we have to find Laplace transform of cos bt, and in this result we need to replace s with s plus a. Since here the function is multiplied by, here cos bt is multiplied by e power minus at, so in the final result we need to replace s with s plus a, and the formula for Laplace transform of cos bt is s by s square plus b square, and here replace s with s plus a, and the answer will be s plus a by s plus a whole square plus b square. And one more result using hyperbolic function, Laplace transform of e power at into cos hbt. So here we need to find Laplace transform of cos hbt, and in this result we need to change s with s minus a, since this function cos hbt is multiplied by e power at. So whenever we have e power at in the final result, we need to replace s by s minus a. So this is equals to L of cos hbt formula is s by s square minus b square, and in this result wherever we have s, that must be replaced by s minus a. So finally we get s minus a by s minus a whole square minus b square. So these are the few applications of first shifting theorem and examples on first shifting theorem. And the first example is Laplace transform of t square e power 2t. So in this example, the function f of t, that is t square, is multiplied by e power 2t. So here, to find the Laplace transform of this function, we have to apply first shifting theorem. By first shifting theorem, we have Laplace transform of e power at into f of t equal to f of s minus a, where what is L of f of t? L of f of t is nothing but f of s as per the definition. In this example, f of t is equal to t square. Then by previous result, L of e power 2t into t square can be written as, first we need to find Laplace transform of t square, and then we need to change here s by s minus 2. Why we are changing s with s minus 2? Since here the function t square is multiplied by e power 2t, where here a is nothing but 2. A is nothing but 2 the power of e in the coefficient of t. So now this is equals to L of t square formula is 2 factorial by s power 2 plus 1. And here in this result we need to change s with s minus 2. So now finally the answer will be 2 by s minus 2 whole cube. And the second example is Laplace transform of e power 2t into 3t power 5 minus cos 4t. So we need to evaluate this using first shifting theorem, since this function is r f of t and this function is multiplied by e power 2t. So that's why we need to apply the first shifting theorem. So now by first shifting theorem, we have L of e power at into f of t equal to f of s minus a. So using this result, the function f of t is equal to 3t power 5 minus cos 4t. So now to evaluate Laplace transform of e power 2t into 3t power 5 minus cos 4t, first I need to find the Laplace transform of this function f of t, where f of t is nothing but 3t power 5 minus cos 4t, and here in this result we need to change s by s minus 2. Now using linearity property of Laplace transform, this function can be written as 3 into Laplace transform of t power 5 minus Laplace transform of cos 4t, and after getting the result, change s with s minus 2. And by using the formula, L of t power 5 can be written as 5 factorial by s power 5 plus 1 minus cos 4t formula is s by s square plus 4 square, and here change s to s minus 2, which is equals to 3 into 5 factorial is 120 by s power 6 minus s by s square plus 16, and here in this result we need to change s to s minus 2. So by changing s to s minus 2 we get the final result as 360 by s minus 2 whole power 6 minus of s minus 2 by s minus 2 whole square plus 16. Now we will discuss one more example on first shifting theorem. So in this example, f of t is equal to sin square t. So now Laplace transform of e power minus t into sin square t can be written as Laplace transform of sin square t, where we need to change s with s plus 1, since here the function sin square t is multiplied by e power minus t, where here t coefficient is minus 1. So that's why we have to change s with s plus 1. And as we know, Laplace transform of sin square t is 1 minus cos 2t by 2. Now here in this result, finally we need to change s to s plus 1. So now using linearity property, this term can be written as 1 by 2 into Laplace transform of 1 minus 1 by 2 into Laplace transform of cos 2t. So now change s to s plus 1. By taking 1 by 2 common, we get Laplace transform of 1 minus Laplace transform of cos 2t, and here change s to s plus 1. This is equals to 1 by 2 into Laplace transform of 1 is 1 by s minus Laplace transform of cos 2t is s by s square plus 4, and change s to s plus 1. So this is equals to 1 by 2 into, here after simplification we get the LCM as s into s square plus 4, and in the numerator we get s square plus 4 minus s square, and here in this result we need to replace s with s plus 1. Now after cancellation of s square, we get the term as 1 by 2 into 4 by s into s square plus 4, and here we need to change s with s plus 1. So cancelling this term gives 2 into 1 by s into s square plus 4, and change s to s plus 1. This is equals to 2 into 1 by change s to s plus 1, which gives 1 by s plus 1 into s plus 1 whole square plus 4. After simplification, we get the final result as 2 by s plus 1 into s square plus 2s plus 5. So this is about first shifting theorem. Thank you.